Hello and welcome to today's podcast. This episode is brought to you by Voltmeter, a trusted manufacturer and exporter of precision electrical test and measurement instruments, delivering reliable solutions for industrial and commercial applications. In electrical panels, accurate monitoring of voltage is not just important, it is critical for ensuring system stability and safety. Even small fluctuations or unnoticed irregularities can lead to serious operational issues if not detected in time. In today's podcast, we will explore the role of voltmeters in electrical panels, understand the differences between AC and DC voltmeters, their working principles, types, applications, and how to choose the right voltmeter for panel design. So let's get started. To begin with, let's understand the role of voltmeters in electrical panels. A voltmeter is a device used to check whether electrical power is being supplied continuously in real time. It helps identify voltage drops and also alerts when an overload occurs, allowing professionals to detect issues without disrupting the entire system. In practical panel applications, voltmeters work closely with operators, relays, and circuit breakers. This coordination removes guesswork around power conditions. Because voltmeters provide immediate visibility into voltage fluctuations, they help teams identify irregularities before they turn into major problems. In many ways, a voltmeter acts as a validation tool for the system. It is one of the most important electrical measuring instruments used to check how power flows through a panel. Ensuring that the supplied voltage stays within acceptable limits is a key indicator of how reliable the panel is. Now that we understand their role, let's move ahead and understand the difference between AC and DC voltmeters and how they are used in panels. An AC voltmeter measures alternating voltage, where the current changes direction periodically at a specific frequency. This type of voltage is commonly found in grid supply lines and distribution systems. On the other hand, a DC voltmeter measures direct current, where the flow of electricity remains constant in one direction. This is typically used in batteries, solar systems, and DC control sections. Both AC and DC voltmeters function differently. AC meters evaluate a continuously changing waveform before displaying a usable value, while DC meters directly read a stable voltage. This difference becomes very clear when inspecting the internal sections of an electrical panel. Now let's understand three critical differences between AC and DC voltmeters, especially from a panel builder's perspective. The first difference lies in the type of voltage being measured. DC voltage remains constant, while AC voltage continuously changes in both magnitude and direction. AC meters calculate an effective value before displaying the result, whereas DC meters directly show the voltage level. If the wrong type of voltmeter is used, it can lead to inaccurate readings. In many cases, this issue only becomes noticeable during live testing, when the readings do not match actual conditions. The second difference is related to how these voltmeters are applied inside electrical panels. DC voltmeters are typically used in control sections, battery banks, and UPS systems where voltage remains stable. In contrast, AC voltmeters are used in supply lines, transformer outputs, and distribution sections where voltage is alternating. Modern panels often use digital voltmeters, including multifunction devices. However, it is important that the configuration of the meter matches the type of waveform being measured. The third difference is the impact on panel instrumentation and safety. AC and DC meters operate on different working principles. Most DC meters use a moving coil mechanism where the pointer moves directly based on current flow. AC meters, however, rely on moving iron or electrical principles and often use rectifiers and filtering to process changing signals. Because AC meters involve additional processing, they may sometimes be less accurate, especially when the waveform is distorted. These differences are important because they directly affect the stability of panel instrumentation and overall system compliance. To simplify this comparison, AC meters deal with alternating current and processed readings, while DC meters handle direct current with straightforward readings. AC meters are mainly used in supply sections, whereas DC meters are commonly used in control circuits and battery systems. Now, let's move ahead and look at the different types of voltmeters used in industrial panels. Panel builders usually choose between analog and digital voltmeters based on the application and working environment. Analog DC meters, which use moving coil mechanisms, are known for their simplicity and reliability. Analog AC meters, on the other hand, show voltage changes using electromagnetic responses. However, digital voltmeters are becoming more widely used because they offer clearer readings and better reliability. This makes them a preferred choice in modern electrical control panels, especially in industrial environments where both safety and efficiency need constant monitoring. Now, let's understand how voltmeters actually work in panel monitoring systems. The basic working principle of a voltmeter is to measure the voltage difference between 2 points in a circuit. In DC systems, the voltmeter allows a steady current to pass through its internal coil, producing a stable output. In AC systems, the voltmeter converts the changing waveform into a steady reading that can be displayed clearly. This understanding becomes especially important when voltmeters are integrated into PLC systems. Many modern panels rely on continuous voltage monitoring to collect data and generate alerts, making accurate voltage measurement essential. Moving ahead, let's understand how to choose the right voltmeter for electrical panel design. The first step is to verify the voltage range and determine whether the system uses AC or DC. Next, it is important to check the accuracy class of the meter and ensure it is compatible with other components in the control panel. You should also make sure that the meter meets system requirements in terms of isolation and proper rating. Another critical step is to test the voltmeter under actual load conditions during panel design. Relying only on catalog specifications may not reflect how the meter performs in real-world scenarios. Making the right selection at this stage helps prevent operational issues later. Now let's look at some common mistakes made while selecting voltmeters for panels. One common mistake is using a single meter to measure both AC and DC, which often leads to incorrect readings. Another issue is ignoring waveform distortion, which can result in inaccurate readings, especially in AC systems. Neglecting proper isolation can also create grounding problems within the system. Additionally, not properly evaluating the meter before selection can lead to instability during operation. Finally, let's wrap up the key takeaway. Choosing the right voltmeter is essential for maintaining system accuracy and ensuring long-term reliability of electrical panels. At BMIT, these details are given high importance. Their voltmeters are designed to deliver consistent and precise readings even in demanding industrial environments. For those evaluating instrumentation options, understanding how to select the right measuring devices can make a significant difference in performance and safety. That brings us to the end of today's podcast on the role of voltmeters in electrical panels and the key differences between AC and DC voltmeters. Choosing the right voltmeter plays a crucial role in ensuring accuracy, safety, and long-term system reliability. Thank you for listening. If you found this episode helpful, please like, share, and subscribe for more informative content. To explore reliable and high-performance voltmeters for your applications, you can visit bmit.com. Let's wrap it up here. Thanks again for listening.